Good evening, dear students. Good evening. Yes, dear students. Welcome, dear students. Welcome to the Gradeup, the India's largest e-learning platform. Yes, dear students, come on, join the session very fast. One second. So yes, dear students, come on, join the session. Hello, Harsh. Yes, Madhavan, Krupal. Very good evening, dear. Very good evening. Yes, Harsh. I tried to cover the major part of this casting technology today. Come on, join the session and share this session amongst your friends, dear students. It is very important. Yes, भाई लोग अटेंड करना चालू करो, ज्वाइन करना चालू करो. Shubham, very good evening, dear. Very good evening. So, come on, fast. Yes. So, dear students, this is the series or short about this manufacturing or the production engineering, dear students. From today, we are going to start these sessions for this crash course, and we will be having the 8 sessions. Within that, we are trying to cover the entire manufacturing technology or entire production engineering. Yes, this is the first class, dear students. So come on, every day I am going to be here at 7 p.m. So be there at 7 p.m, dear students. We will be discussing very good things regarding to the various topics. Like today I am going to start with the casting technology. Tomorrow we will be having the welding technology. Day after tomorrow we will be having the forming. Then will be having the sheet metal working, metal cutting. I have put the 2 special sessions for that. We are going to cover up with the non-traditional machining, advanced machining methods, and ultimately with the metrology and inspection part also we are going to cover in this series, dear students. So yes, definitely all the sessions are planned as per the schedule which are running for this crash course. Okay, we will get all the things. Come on, join this session. So dear students, this is about me. I am Onkar, having more than 10 years for the experience for teaching GATE and ESE. I have mentored more than 10,000 number of students for GATE and ESE. My area of expertise are the production and industrial engineering, fluid mechanics, mechatronics and robotics as well. So dear students, are you aware about these things? 19 December we will be having GNST, that is Gradeup National Scholarship Test. So register now for this. There is a free registration for this examination, dear all. Edwin, good evening. Karthik, yes, I am speaking English only. Karthik, don't worry. Sharmila, very good evening. Aditi, very good evening. So dear students, yes, so please register for this test. There will be the test, this Gradeup National Scholarship Test. Okay, you can see here there is a pool of 50 lakhs, scholarship pool of 50 lakhs. So be the part of this test. And if you want to know the timetable for the examination, see, it is in front of you, dear students. Check it. So go through this timetable slots and the actual time, test duration. Also will be giving you the syllabus for this. Okay, you just go and go on our website, dear students. Go to the app. Okay, see, interface is there, app, web is there, desktop is there, and this is the syllabus. This is the syllabus for mechanical engineering, mathematics covering 20 questions, general aptitude 10 questions, and the test is covering only MCQ questions, multiple choice. Okay, we will be not adding here. Yes, MCQs are there and MSQs are there, also there. Please see it here, there. See, 5 MSQs, then NAT 10 questions, MCQ 20 questions, like that. All the summary is given here. If you go on app, Karthik, you will come to know, Karthik, or I will be telling you. So I hope it is clear. Go and register for this test. It is going to happen on 19th of December. So there is a scholarship pool of 50 lakhs. So be the lucky one on amongst these appearing students, right? So let us start the today's session. I hope all you get registered. So dear students, so this is the course actually that we are considering that. So you are having some of the idea regarding to the subject. Okay, you are having the idea and you have well prepared for the subject. Okay, and now here we want to boost your the marks out of 100, more than say 60, more than 70. For that we will be having this kind of crash course. So definitely this is the course or the sessions regarding to the casting and every topic in the production engineering. So today is the first topic that we have taken as a casting technology. Now for this casting technology, you know well, the casting is one of the first the metal shaping process that we have, that the humans are known. Okay, this is very first manufacturing process, and the ability of that process is that any kind of material as well as any kind of complex intricate shape we can very easily able to make by this casting process. Okay, now after knowing this, it is not sufficient for our syllabus or our gate examination, right? So there are a lot of things are there. Okay, starting from the say the various kind of allowances we are going to learn, or we already learned it. So we are having the shrinkage allowance, we are having the draft allowance, we are having the taper, that is draft, shake allowance, distortion allowance. Okay, so all the allowances we have learned. And the first question, this first numerical is basically, yes, it is on the allowance giving, how to give the allowance and how to calculate the ratio of the volume of pattern to that of volume of casting. So be there and please let me know whether you are having the calculators. So see here, so in all the upcoming sessions definitely we are going to solve the questions, dear students. So be there with the calculators and be interactive. Okay, and try to solve the equations, try to tell me the value so that we can directly write there. So help me in that manner so that we can solve togetherly the questions. Are you ready, guys? So this is the first question that we have. The casting shown in the figure is made up by the plain carbon steel using the wooden pattern, assuming only the shrinkage allowance of 21 mm per meter. Okay, the ratio of volume of pattern to that of volume of casting they are asking. Okay, please, how much when you are providing the allowances. Which allowances? Shrinkage allowances. Now dear student, little bit some things I want to clear here. I hope you know this. Okay, so dear students, as you know that the shrinkage allowance definitely we are going to give on the external as well as the internal dimension. Okay, external dimension as well as the internal dimension. Say external dimension, as you can see in this question, these are the external dimensions, and you can see one bore is there in this slab. This is the internal dimension. So the rule that you know very well, dear students, what is the rule? That on the external dimension as well as on the internal dimension, these two are of course going to shrink. Okay, of course, when I am saying that the material is shrinking or it is undergoing the contraction during the shrinking, right? So it is going to say shrink. The external dimensions also going to shrink. And dear students, please remember that this internal dimension also is going to shrink towards the center. Okay, towards the center, this internal dimension is also going, this bore is also going to shrink toward the center. So the thing is that you have to provide the positive shrinkage allowance, on external dimension as well as on internal dimension. Okay, and of course when the material they are mentioning like that, suppose there is a bismuth. Okay, so the material bismuth which is going to expand during the solidification, during cooling, so no doubt you can go and provide the negative allowance in that case. But dear students, generally maximum materials are going to shrink when they are cooling from the liquid molten metal temperature to the room temperature. Okay, including the cast iron also, including the gray cast iron also, they are going to shrink. Okay, now here the shrink rule says that all the external dimensions and also the internal dimensions are going to shrink during this solidification. So definitely we have to provide the positive shrinkage allowance, that is the very important thing. Okay, both on external dimensions as well as on the internal dimension, we are going to provide like that positive shrinkage allowance. Now what are the dimension, dear students, that we have? Sudarshan Yadav, very good evening. So this is our slab, and what is the dimensions for that slab? So length is 200 by 150, 200 by 150 by how much? 100, and bore is of 80 mm diameter, and bore is of say 80 mm diameter, 80 mm, phi is 80 mm. So tell me what will be the dimensions? Length will be how much? Tell me. I will write separately for length, then I will write separately for width, and I will write separately for the height. Tell me how much is the length after provision of shrinkage allowance, because they are going to contract, and that is the reason why to compensate that contraction we have to provide the shrinkage allowance. Okay, so how much shrinkage allowance they are showing? 21 mm per meter. So for every 1 meter we are going to provide 21 millimeter as a shrinkage allowance. Okay, so you can of course provide the shrinkage allowance in terms of percentage over dimensions. Okay, and if there is a say liquid shrinkages that we have, we can have presentation in terms of the volume, percentage over volume we can give. Now dear students, tell me what is the length? Initial length is 200. Okay, on that we are going to provide 21 mm per meter. 21 mm per meter means how much millimeter? 1000 millimeter. Okay, on which dimension? 200 mm. So tell me what is the value of this? So 21 divided by 1000 into 200. How much it is? 4.2, isn't it? 4.2 mm. So that is this 200 plus 4.2, that will be 204. I will say for the rounding off, I will say it is 204 millimeter. That will be my new length when I provide the shrinkage allowance. Yes or no, dear students? Come on, interact with me. Tell me the values. Tell me about what is the width. Width is initially 150. Now it is going to shrink. So I have to provide the shrinkage allowance, positive shrinkage allowance. Okay. So it will be how much? So 21 divided by 1000 into 150. How much it is? 21 divided by 1000 into 150. How much it is? It is 3.15. 150 plus 3.15. How much it is? 153.15. Say it is 153. Isn't it? Or you can have 3.2 also. Take the next. Very good. Sharmila, very good. Karthik, very good. 153.15. Okay, very nice. Mm. And yes, the height will be how much? This 100 plus 21 divided by 1000 into 100. Tell me how much it is. Tell me how much it is. It is 2.10. That is 102.10. 102.10. That is correct. That is correct. Absolutely correct. Yes, Sharmila. Now, what is about this internal dimension? That is the bore is there. How much the value for that bore? So bore dimensions will be how much? So please remember that many of the things are confusing there. In case of the whole, dear student, no need to confuse. So bore is also going to shrink toward the center. So for that we have to provide the positive shrinkage allowance, and only one time, So it is 80 mm. So 80 plus 21 mm per meter into 80. Tell me how much the bore dimension? 21 divided by 1000 into 80. So that will be 80 plus 1.68. I will round off to 1.67. So 80 plus 1.7. Okay, so it will be 81.7 mm. Okay, Harsh. Now please, dear students, come and join the session. This will be very important for you guys. Okay, 81.68, Sharmila. So I have round it out to 81.7. No issue. Excellent, Karthik. Harsh, 96.8, dear. What you are calculating? Right. Now see here. Now you have got the dimensions of the pattern. So pattern is what? Now it is having the oversize. You know the pattern size equal to what? Pattern size, it is a replica of the casting is to be produced, which is equal to casting size plus or minus allowances. So in this case we have added the allowances because material is like this, which is going to shrink, right? So definitely casting size plus allowances, we have got all the dimensions. So tell me what is the length. New length is how much? It is 204.20. Yes. What is the new width we are having? New width 153.20, round up to 20, and it is 204 point how much? It is 4, na? So it is, I will write it as it is 4. Okay, this is 153.20, rounding off, and height will be how much? 100.10, 102.10, and at the same time, what is bore dimension? Phi is equal to now? It is 81.7. Now what they are asking in the question? They are asking in the question volume of pattern to the volume of casting. How much? So calculate the volume of pattern now. So there is a volume of slab minus, if you minus the volume of that bore, you will get the slab, the net volume, isn't it? So volume of slab में से अगर वो bore dimension मैंने neglect किया या reject किया, subtract किया, definitely I will get what? The volume of that pattern. That is volume of slab minus volume of the bore. I will get the volume of pattern. So what is that? So slab is what? Volume of slab, that is 204 length into width 153.20 into height 102.10. Okay, that is the volume of that new slab, that is pattern, minus that is the bore here. You can see here, this is a bore. This is a bore here, cylindrical bore of say this 80, and the height was how much? 100. So this we have to minus from the slab, you will get the net volume, isn't it? Yes, tell me the answer, tell me the answer. So minus pi by 4, what is diameter? New diameter will be 81.7 whole square into new height will be how much? 102.10. Tell me what is the net volume we are getting, volume of pattern you are getting? That is 204.40, 204.40 into 153.20 into 102.10. It is 3.197 3.19716 into 10 to the power 6 minus, what is the bore dimension? 81.7 whole square times pi divided by 4 into 102.10. How much it is? Is it 535.253 into 10 to the power 3? Check it out, check it out. So 3.197 e to the power 6 minus answer. It is 2.661 into 10 to the power 6 mm cube. And what is volume of casting? Volume of casting is how much? It is 200 by 150 by 100 minus pi by 4. Diameter was 80 whole square into height 100. So yes, dear students, tell me the volume of the casting. So 80 square into 100 pi divided by 4, it will be 502.65 into 10 to the power 3, and here 200 into 150 into 100, so it is 3 to the power 6, 3 into 10 to the power 6 minus 65 e to the power 3. So it is 2.497 into 10 to the power 6 mm cube. Now tell me the answer. Tell me the answer. Volume of casting is known, volume of pattern is known. So volume of pattern divided by volume of casting is how much now? Yes. 2.661 into 10 to the power 6 divided by 2.497 into 10 to the power 6. So it is how much? 2.661 divided by 2.497. It is 1.06. Yes, Harsh. Sharmila, very good dear. 1.06. VP by VC will be how much? 1.06. That is correct. That is absolutely correct. So dear students, don't only attend the session. Please participate karo beta, participate in the session, calculate the things. So 1.06 is the correct answer. So one thing that you understand, whenever there is a shrinkage allowance and material is shrinkage, material is having the contraction during the during the cooling, definitely you have to provide the positive, भले हो external dimension हो या फिर internal dimension. Okay, that is very clear thing. Dimension. Okay, very good. Yes, Karthik, very good. Edwin, very good. Harsh, very good. Sharmila, very good. So remaining also you can join and start solving the question. Next question. So provide the draft allowance to the pattern after providing the machining allowance in the example C. So we have not provided any machining allowance, but I will give you the dimension where you can have the machining allowance. Okay, so after providing the machining allowance, suppose your dimensions are now like this. Okay, so this is the dimension given to you. This is length is now 211 say, and height is now, say it is 109 mm. Okay, so now bismuth expand. Yes, Harsh. So intermolecular, due to the intermolecular vibrations at the higher temperatures, amplitude get amplified for the vibrations, and that is why bismuth is the material which is purely expand during the cooling, right? Allowance is added to the internal. See, I told you, Sir Mr. already. See, whenever suppose we are having this hole, okay, this is hole is there onto this sheet. So as when you are having the cooling of that material, that is the sheet is here, okay, along with sheet I am showing you the hole. So as I told you, because of the cooling, when the material is subjected to the contraction, okay, if all the dimensions are shrinking like this in all the way, okay, so dear students, please understand that ये जो hole होता है, this hole is also going to contract toward the center of this circle, okay, by an amount, same amount with which the external dimensions are shrinking. Okay, so please, that is the shrink rule. Actually, this is the first rule for the shrinkage. Yes, external as well as internal dimensions are get shrinking. It's not like that internal dimension is going to be get bigger or the external dimension is going to be get smaller. It is not like that. Okay, when it is possible like this, when you are providing the machining allowance. Okay, so if in this situation, please understand, when I say provide the machining allowance, okay, say like 3 mm per side, okay, for every side provide 3 mm, and I say for the bore also, if you go on providing 3 mm per side. So how you are going to provide the machining allowance? Tell me machining allowance, how will you provide? Whenever in the question, if instead of shrinkage allowance they ask you to provide the machining allowance and tell me the final volume of the pattern, so in that case, so already see Matraju Raju, I told you why the bismuth is expand. At higher temperature, intermolecular vibrations in the bismuth are get amplified, and that is the reason this bismuth is always expanding rather contracting. Okay, so only that material, and that is the reason why I tell you, that is the reason why there was a very big reason to choose the bismuth as a material when we are go some in the flashback. Whenever there was a typewriters, we used to have typewriters machines. So the parts on which the letters are marked and that marked letter are going to create the expression on the paper. So these all things were made up of the material called it as bismuth. So why bismuth? So dear students, whenever we are actually having the die casting of the bismuth, okay, please see it very carefully or listen to it very carefully. So what happened to when the bismuth is get entered into the die, in the closed die, what is going to happen when you inject the bismuth? So whenever there are the very critical impressions like the letters or some embossings are there into the die, so that cavity, this die cavity, we have to ensure that it should get filled at each and every corner. That is our intention. So what happened? Bismuth, what actually happening with the bismuth? When bismuth getting cooled down, it's going to expand. And then we need not to worry, when the bismuth is injected into the die, during the solidification, it is going to expand. So automatically, where are the very keen or where are the very intricate shapes in the die? So automatically, when the bismuth is expand, it will going to fulfill or feel that impression in the die. I hope it is clear, and that is the reason why, see, bismuth was very useful material when you are talking about this printers. Okay, I hope it is clear to you. So we need not to worry about that. What actually happened, where we are going to get the all correct impressions in the material or not. okay, on the object or not. So this is the thing. Okay, now dear students, yes, if I provide the machining allowance, what is the scenario? See, machining allowance is provided as, so length will be what? The length plus 2 times machining allowance. Okay, width will be was why 2 times? Because from the two sides we are going to machine this length also, from this side also and from this side also. So we are having the machining on that. Okay, when you talk about the width, so width is also going to machining from two sides, both the sides. So machining allowance, it should be get doubled. When I talk about the height, so from the top, from the bottom, from both the sides it is going to machine. So it is having the height is equal to 2 times machining allowance. So all the external dimensions, see, for all the external dimensions, you will be adding this machining allowance as 2 times the machining allowance. Okay, twice of that machining allowance. But dear students, now the time for providing the machining allowance for the internal dimension. So tell me, so whether this bore of diameter D is going to be how much? It should be D plus 2 times machining allowance or D minus 2 times machining allowance. Sunil Patel, hello dear. So see, whenever the machining allowance is provided on the bore, it should get minus or it should get subtracted. Then and then only the dimension becomes small and you will get the provision to enlarge this dimension with the provision of the machining. Isn't it? So yaad rakhna. So when you are having the machining allowance, you are providing the extra material on the casting because you want to get the required surface finish. You are going to remove that material. So in case of bore, when you are providing the extra dimension, means what? The bore size going to be get lesser or smaller, and same material will be removing in terms of machining to get the required value of that bore. So please remember that. So machining allowance, what happened whenever machining allowance is there onto the bore, definitely the dimension of the bore should get minus, should get minimum. So in that case, suppose I am having 3 millimeter machining, 3 millimeter per side is my machining allowance. Okay, onto the bore was how much millimeter? 80 millimeter. So 80 minus, so it will be 2 times. For it is a radial one, isn't it? So 2 times 3, so it will be how much? 76 millimeter after provision of machining allowance. I hope it is clear. Okay, fine. Now here, what is our question? So very fast, just calculate the dimension when we are providing the draft allowance. Come on, very fast. So see here, we are providing the draft here, that is a taper allowance. Okay, what they are saying, external dimension, how much taper? You take the external dimension 0.75 degree, and on internal dimension, on internal taper, you will get it as 1 degree. So how your pattern is going to look like? It is going to look like this. Externally, it is look like this because of the provision of this taper, and internally it is going to be look like this because of say taper, right? So calculate the external taper, internal taper very fast and tell me the dimensions. So only you have to calculate this dimension because this dimension is going to increase by the taper. Yes, why 2 times? Why 2 times? When I am saying, say I want to machine this, say this is slab and you want to machine this, so definitely you are going to machine from this side also and from this side also. When I talk about the width, you want to machine it, you are going to machine it from this side, you are going to machine it from this side. I want to talk about length, you are going to machine it from this side and from this side. So 2 times are there. Internal also 2 times. Radial, it is internal, it is radial. Yes, tell me the value. So it is 211. So this is actually 211 and this is 109. So 211 becomes how much, tell me? So taper, external taper how much? 0.75 and internal it is 1 degree. Okay, so suppose this is the enlargement of, like this also, enlargement of this x here, and there is a decrease of y here and y here. Okay, tell me the values. So here if I having this taper as 0.75, so tan of 0.75 is equal to this x divided by height is how much? 109. So tell me x is how much? And if I have here tan of y, so tan of 1 degree is equal to y divided by again 109 is the height. You can tell me the value of y. Tell me very fast. Tan of 0.75, tan of 0.75 into 109, that is 1.426, and tan of 1 into 109, that will be how much? 1.90. Okay, so now see here dear, from this side on this 211 you are going to add the x 2 times, this one and this one. So this length will becomes 211 plus what is x? 2 times 1.426. And here because of the provision of taper, this internal dimension it is going to be get changed from say 80 mm, or because from after provision of the machining allowance it is actually 76 mm, no? So 76 minus this is y here and this is y here, so 2 times y is how much? 1.90. Tell me final answer. Tell me the final answer after provision of the draft allowance. So 211 plus 2 times 1.426, it will be 213.85 millimeter, and this bore at one end will be, because provision of the internal taper, 76 minus 76 was the value after providing the machining allowance of 3 mm, that will be minus 2 into 1.90. how much it is? It is 72.2 mm. So these are the final dimensions. So these are the final dimensions. So it is look like this. So this is something 72.2 and this is something 213.85. Okay, I hope it is clear. I hope it is clear. Yes Karthik, it is clear. Very good, very good. Kharse, Akhilesh Kharse, yes. Very good. Take the next question now. See, allowance calculation is clear. See, there are chances to have the question on the allowance. So allowance calculation is there. It is corrected and clear. Even there is a gray cast iron. Please remember that gray cast iron is not going to expand. Okay. Only the thing is that their amount of getting contraction, it may get increase or it may get decrease based upon the graphitization. More will be the graphitization, lesser will be the shrinkage, and lesser will be the graphitization, more will be the shrinkage, based on that only. But yes, at the end it is not going to expand. Be clear, be clear. Okay, so next question. Tell me the answer of this question. Yes, the process that produces a casting when pressure forces the molten metal into the mold cavity is known as. Tell me the answer. Yes, come on, join the session. The process that produces a casting when pressure forces the molten metal into the mold cavity is known as. So you should increase the number in the chat box. You should increase the number of attendee the class. Definitely it will be very interesting, dear students. It is very beneficial for you guys only. So try to share this session, like this session, ask your friends to join this session. Yes, die casting is correct answer. In die casting we are, see, there are two casting techniques in die casting. There is a gravity die casting, there is a pressurized die casting. In pressurized die casting we are injecting the material into the die with certain amount of pressure, force, that is the pressurized die casting. And whenever the flow of molten metal into the die cavity with the help of gravity action, there is a gravity die casting. The example of gravity die casting you know very well, the piston of aluminum alloys. Yes or no? That is made up of the gravity die casting. And the carburetor or carburetor's parts, very intricate complex parts, are definitely made up with the pressurized die casting. So you know very well. So C is the correct answer. C is the correct answer. Abhilash, very good. Karthik, very good. Harsh, very good. Sagar, very good. So come on, dear students. Tell me this question, answer of this question. Tell me the answer of this question, dear. So you know that, see what I am expecting, that you should have the clarity on all these things, on the very basic things on the metal casting, like what are these allowances, how they are provided, what is this freezing time or solidification time of the casting, what is pouring time for different gating systems. I am expecting that you know all these things. Based on that we are having these questions. So you know that the Vorino's rule say that the solidification time for the casting is equal to K into bracket the volume of casting divided by surface area of casting to the power 2 whole square. Okay, so where K is the mold constant or solidification constant, mold factor, whatever you can call it as, mold factor, solidification constant, whatever. I am not going to derive the expression. We can derive the expression for this Vorino's rule. No any big deal. But ultimate result is this. You know that solidification time is equal to mole factor into bracket volume of casting divided by surface area of casting whole square. Now tell me, this is proportional to the what? Volume of casting square, and it is inversely proportional. This tau s is inversely proportional to what? Surface area of casting. So see here, inversely proportional to the square of the volume, it is not correct. Directly proportional to the square of the surface area, not correct. Inversely proportional to the square of the surface area, yes. Directly proportional to the square of the volume, yes. So 3 and 4 are correct. So B, Bombay is the correct answer. B, Bombay is the correct answer. Yes, next question, dear students. Yes. So based on this only we are having this question on the Vorino's rule, solidification time, how to calculate solidification time. So see here, consider a spherical drop of molten metal which has the radius, say R1. If I write R1 is the radius of 3 mm, and this it's going to solidify within 10 seconds. And a similar drop, that is drop made up of the similar material, molten material, the radius will be 6 millimeter, say, and they are asking how much time it will require to get solidified. So tau is how much for the spherical drop of molten metal having the radius 6 mm. So see here, we know that the solidification time is equal to K into bracket V by AS whole square, right? And here same molten material, matlab mold constant is what? It is same for both the cases. Say K get cancel out, and what they are saying? Okay, So if I write here this tau, and simply if I want to calculate the modulus, what is mean by modulus? So modulus means the ratio of volume of casting divided by surface area of casting. Surface area of casting. So see here, volume of spherical casting will be what? 4 by 3 into pi r cube divided by surface area is what? 4 pi r square. So see here, 4 cancel out, pi cancel out, so you will get r upon 3. That is nothing but, you know very well, the modulus of casting. You take the side cylindrical riser if you take, or you can take the spherical riser. The definitely in case of riser I am saying it is d by 6. It is equal to d by 6. But here what we are getting, we will put it in terms of the r by 3 only. So what we will get here? So it is nothing but r by 3 whole square, isn't it? So if I write here tau 2 divided by tau 1, which is equal to r2 by 3 divided by r1 by 3, that is 3 divided by r1 whole square. Yes or no? So tau 2 is equal to, tau 1 is how much? 10 seconds into 3 gate cancel out. R2 is how much? 6 millimeter. R1 is how much? 3 millimeter whole square. So it will be equal to what? Tau 2 will be equal to 10 into bracket 3 2s are 6, so 2 square, so 10 into 4, it will be 40 seconds. So the spherical casting of radius 6 millimeter will be get solidified within this 40 seconds. Very good, 40 is the correct answer. I hope it is clear. 40 is clear. Yes, Karthik, very good. Yes, anybody is there who are calculating? Kharse, Padmat, very good. 40 seconds, very good. Kharse, where are you? Sagar, yes, very good, very good, very good, very good. Next question. So see here, this is the question where we are interested to find out the diameter of the sprue at point B and at point A. Okay, now see, I will just clear the background about this. So we know very well, that is, there is one very famous ratio that we are getting in case of the casting, that is the area ratio. Area ratio, which says that area ratio R is given as A3 divided by A2. This is say 0.2, this is 0.3 base of the sprue. Okay, here is molten metal is here, this is the cup height, this is the sprue height, and the addition of these two will be giving us the total height HT, that is total head available for 0.3. Okay, you know that velocity at point 2 is given as root over 2g hc, and velocity at point 3 is given as root over 2g ht. And from that, dear students, we are getting very famous formula. This A3 divided by A2 is equal to root over HC divided by HT. That is very well known. Okay, from this formula, we can very nicely able to calculate the diameter at point 2 or the diameter at point 3. Only the thing is that if we apply the continuity equation at point 2 and 3, definitely you can able to write the flow rate. Discharge is equal to A2V2 is equal to A3V3. Okay, so now in the given question, now come to the question. What is given? So there is a mass flow rate is given. Mass flow rate is given 20 kgs per second. Okay, what is the material? That is the iron is there, having the density 7800 kgs per meter cube, isn't it? So definitely from this you can able to calculate the discharge. Discharge is what? That is mass flow rate into density. Yes or no? So mass flow rate is how much? 20 into 7800. Tell me how much is the discharge. Isn't it? Is it okay? Sorry. M dot is equal to rho times Q. That is correct. Sorry. What is the formula actually? We have learned it in the fluid mechanics. Okay. M dot is equal to rho into Q. Isn't it? So M dot is how much? 20 is equal to rho 7800 into discharge or flow rate. It is a Q. So tell me how much Q discharge you are getting. Tell me the value. 20 divided by 7800. You will be getting 2.56 into 10 to the power minus 3 say meter cube per second. That is the discharge. Okay, that is the discharge you are getting. Now if you going to calculate this Q as equal to this A2 into V2. So tell me what is value of V2, because see there is a cup height, that is molten metal in the cup up to 9 centimeter, and the sprue length is how much? 25 centimeter. So tell me, so if I write here the discharge is what? 2.56 into 10 to the power minus 3. Okay, that will be how much? Harsh, what is not clear dear? Tell me. Very simple concept, very simple. See, what I am seeing, I am hoping that you know these things, and based on that only I am moving forward. This crash course is based on this thing only. I am expecting that you should have the knowledge of very basic thing, required thing for the casting, not for the casting, for every topic, and based on that only we are going to build the block, like we are solving the questions. So if you apply the continuity equation at point 1 and 2, what you can write? A2 V2, suppose this is instead of 2 and this is 3, A2 V2 is equal to A3 V3. Okay, that is what you are going to get the discharge. But here discharge is not mentioned. Here mass flow rate is given, M dot. How much mass flow rate is there? 20 kgs per second. And density of the molten material is given. Density is how much? 7800 kgs per meter cube. So if this is given, you can able to calculate the Q, that is M dot is equal to rho Q. In impulse movement equation you have write this, that is M dot into bracket velocity of object minus a velocity of subject, that is rho Q into bracket change in velocity. So based on that only we have written the things. Now this Q is known to you. Tell me A2 into V2 is how much? Root over 2 into 9.81 into what is the height of the cup, molten metal in the cup, it is 9 into 10 to the power minus 2 meter. Tell me the value of A2. So it is how much? So 2 into 9.81 into 9 into e to the power minus 2 root over answer, it will be 1.32 meter square. And area is what? It is circular cross section pi by 4. See, d2 square is equal to 1.32, that is multiplied by 4 divided by pi and root over answer. I will be getting 1.33. How much it is? 1.32 into 4 divided by pi root over answer, it is 1.77. Is it okay? Diameter at A is how much? Diameter at B is how much? Are you doing the calculations? Tell me, calculate the things and tell me. V2 how much you are getting? So 2 into 9.81 into 9 into e to the power minus 2 root over answer 1.32. Yes, 2.56. So V2 is 1.32 Okay, okay. V2 is 1.32. So C. I will write it here. So A2 will be equal to 2.56 into 10 to the power minus 3 divided by 1.328. So tell me what answer. 2.56 e to the power minus 3 divided by answer. So A2 will be, you are getting 1.92 into 10 to the power minus 3. Okay, and which is equal to pi by 4 d2 square, isn't it? The diameter at point 2 square, it will be how much? So into 4 divided by pi root over answer, it is 0.049 meters. Sorry, it is d2. So it is in centimeter. If you want to write, it will be 4.9 centimeter. So check it the answer. Yes, 4.9 it is at B. Yes, 4.9 you are getting 4.95. Yes, that is correct. 4.9 centimeter. And if you want to calculate the diameter at the cross section at 3, so A3 V3 as equal to Q discharge. Okay, as you know, Q is how much? 2.56 into 10 to the power minus 3 is equal to A3 unknown into V3 is what? Root over 2 GHT, 2 into 9.81, and HT will be how much? HT 25 plus 9. 25 plus 9, it will be 34 centimeter. That will be 0.34 meter. Okay, so 0.34 into 9.81 into 2 root over answer. So we'll get velocity at point 3 will be 2.582 meter per second, and from that you are getting the area. Please check it out. A3 will be this 2.56 e to the power minus 3 divided by 2.582 and square root of this. So area will be getting 9.91 into 10 to the power minus 4, and which is equal to pi by 4 d3 square. So tell me what is the value of d3. So this is multiply by 4 divided by pi and square root of the answer. So it will be 0.0355 meter. So in centimeter it will be how much? Multiply by 100, it will be 3.55 centimeter. So this is the diameter at point 3. This is the answer. Please check it out. Whether you are getting the diameters at point 2 is 4.9 and the diameter this is at this point 4.9 centimeter, and at A it is 3.55. So what is the correct answer? What is the correct answer? A is the correct answer. A option A is the correct. See, 3.55 and 4.96. Isn't it? So next question. Can you solve this question? Let's take this question. Two metal pieces being cast have the same volume but different shapes. One is the sphere and the other is the cylinder. With height and diameter are same. What will be the ratio of solidification time for making the cylindrical and spherical shape? Yes, dear students, try to solve the questions. So two metal pieces being cast have the same volume is same. Okay, so one is sphere. Okay, so one is sphere, that is volume will be 4 by 3 pi r cube, and one is cylinder with height and diameter same, that is pi by 4, d and h same, so it will be say d cube. So what we can write, so 16 by 3 r cube is equal to d cube. There is a relation between the radius of the sphere and the diameter of the cylinder, right? So what I can write, 16 divided by 3 and cube root of the answer, it will be 1.74. so I will write d is equal to 1.74 times the radius of the sphere. So this is the relation I have got. Okay, and now I can write the solidification time for cylinder as to solidification time for sphere is equal to what? The same identical material, so K is going to be the same. So volume of casting divided by surface area of casting, this is for cylinder, into the surface area divided by volume for spherical casting, entire bracket square, isn't it? So calculate. So volume are going to be same, so volume get cancelled out. So surface area for the sphere, I will write surface area for the sphere divided by surface area for the cylinder whole square, that will be a ratio of the solidification time for the cylindrical casting divided by solidification time for spherical casting. So tell me the surface. So during the solidification for the cylindrical casting, so you should take the surface area from here, heat is going to be rejected from here, and from here. Okay, so what is surface area for the cylindrical shape casting? 2 times pi by 4 d square plus pi dh. So that will be pi by 2 d square plus pi dh. And the diameter and height are same, they are saying. So pi by 2 d square plus pi d into d, that is d square. So it will be 1.5 pi d square, isn't it? This is the surface area for the cylinder. And surface area for the sphere is how much? It is 4 pi r square, isn't it? So just write the values there in the formula. In this I will write here. So surface area of the sphere 4 pi r square divided by what is there? 1.5. Say d I am writing here in capital. So 1.5 d square whole bracket square. Tell me what is the value. Now what? R is equal to how much? There is a relation between d and r. D is equal to 1.74. So I will write here 4 pi is how much? 4 into pi, it will be 12.56 r square divided by 1.5, and d is what? 1.74 times r whole square. So how much it is? 1.74 whole square, because it is square there, into 1.5. okay, 12.56 divided by this answer, so it will be 2.76. check it out. So they are asking the solidification time for the cylindrical and spherical shapes. Okay, yes dear students, come on, tell me some values so that I can directly write. So see here what I have written, 4 pi r square for the spherical shape casting divided by cylindrical side shape casting. What we have got? Surface area, whether it is correct? Yes, 3 by 2, that is 1.5 pi d square. 1.5 pi, yes, pi is there, pi d square, and whole bracket square. Okay, so pi get cancelled out, so 4 r square divided by 1.5 into d is what? 1.74 times r whole square, and this is complete square. So it will be how much? So 4 divided by 1.5, it is 2.66. divided by 1.74 bracket square, 1.74 square, it's 3.02 into r square divided by r square and whole bracket square. So r square it cancel out. So 2.66 divided by 3.02 and entire bracket square. So actually it is coming as 0.878 whole square. That will be how much? So it will be 0.77. 0.77 is the answer. Check it out. Arvind, what we missed? हाँ पाई मिस कर दिया था. यस हियर हमने पाई मिस कर दिया था. यहाँ पे पाई लिखना था. पाई पाई कैंसल आउट होने वाला था. यस आई अंडरस्टूड. 0.77. लेट चेक द ऑप्शंस. यस यू कैन. यस अभी अखिलेश, वेरी गुड अखिलेश. 0.77 is the correct answer. 0.77 is the correct answer. Understood how they can ask the question, please. Karthik, very good. D is the correct answer. So no one is there calculating the values, or no one also no one is telling me, sir, the pi is left over, you have not taken pi there. No one is telling. Very nice. Calculate this. A down sprue of 180 mm length has a diameter of 20 mm at its top. Down sprue is there. So diameter is how much here? 20 mm at the top. Okay. And in the cup, how much liquid is maintained? Up to 60 mm height. Okay. And length of the down sprue is how much? It is 180 mm. Okay. So down sprue, the theoretical diameter at this 0.3 they are asking. At this is 0.2, this is 0.3. So what is the diameter? D3 question mark. Come on, solve this question. So in the pouring basin, there is a liquid molten metal up to how much height? 60 mm. The diameter at 0.2, that is top of the sprue diameter, cross section diameter is there, that is 20 mm. And at the bottom, how much it will be to avoid the aspiration effect? To avoid the aspiration effect, definitely the shape of the sprue is parabolic, that we are assuming that A3 by A2, we are getting this ratio, that is equal to root over HC by HT. You know very well. Okay, when you apply this, definitely there will be no aspiration effect. So what is the area at 0.2? So pi by 4, diameter is how much? 20 square. How much it is? How much it is? It is 314.15 mm square. A3 is unknown. HC is how much? 60 mm. Then what is HT? What is HT? This 180 plus 60. Whether it is 240 mm, please check it out. Okay. And now very nicely apply the area ratio. A3 by A2 is equal to root over HC by HT. So how much A3? Unknown, is equal to A2 is how much? 314.15 into root over HC is how much? 60 divided by 240. Tell me the answer. How much it is? Tell me the answer. I'm waiting. Tell me the answer. Cube. Theoretical diameter they are asking. Okay, diameter they are asking. So this is area. Tell me how much area. This A2 is correct, 314. Yes, tell me whether it is correct or wrong. Length has diameter of 20 mm at its top end. Liquid metal is pouring up to 60 mm up to the height. What should be the theoretical diameter of the downspout at lower end? Yes, tell me Karthik, whether it is 628? HC is 60. Yes, that is thing I am shocked. Akhilesh, why 620? I don't know. Check it out. Yes, it is 157.075 mm square. And if you know the area is pi by 4. Arun, very good evening. Pi by 4 d square or d3 square, it will be 157.07. So into 4 divided by pi and root over answer if I take, so it will be 14.14 mm. Please check it out. Arvind, how the diameter will be bigger than the 20 mm? Aspiration कैसे नहीं होगा फिर? So I hope check it the answer. 157.075 is the area at the point 3. Yes, 14.14 mm. 14.14 mm. That is the correct. Yes, that is correct. D3 is 14.14. That's the same thing they are asking. What is D3? At lower end the diameter they are asking. Very good. 14.14. That is correct answer. Let me check. Can you solve this question? Karthik, not asking the area, they are asking the diameter. So 157.7.075 is the area and they are asking the diameter. So it is equal to pi by 4 d square. So multiply by 4 divided by pi and take the root of that answer. Yes, 14.1. Or before that we will just check the how to design the riser. Take this question. Yes. So determine the dimensions of the cylindrical riser to be used for casting as aluminum cube of 15 centimeter. The volume shrinkage of aluminum during the solidification is 6.5%. The height and diameter of the riser are same. Okay, that is, this is kind of the side riser. You assume that this. So definitely by the volume shrinkage consideration method we are going to solve this question. And see, there is a cube. The cube side is how much? 15 centimeter. The liquid shrinkage for the aluminum is how much? 6.5%. Okay, So when we design the riser with the help of volume shrinkage consideration method, so dear students, please tell me whether it is beneficial for you or not. So we are just solving some critical questions, nice questions, so that you can get the practice for those questions. Your confidence should boost up, right? So like that we are going to solve the questions every day for the upcoming 7 days on every topic. So please be there, attend the sessions in large numbers. So see here. So in the volume shrinkage consideration method, what is there? There is a first case, that is the necessary condition, which says that volume of the riser should be greater than or equal to, you take 3 times shrinkage volume of the casting. Okay. Now here, what is shrinkage? Shrinkage volume of the casting. So volume of the riser should be greater than or equal to 3 times. Shrinkage volume is how much? A divided by 100 into volume of casting, isn't it? So VR should be greater than equal to 3 into how much the percentage of shrinkage for that material? 6.5 divided by 100 into volume of casting is how much? 15 cube, because it's a cube. So cube की volume क्या होती है? Side cube. So definitely 15 cube into 6.5 into 3 divided by 100. So if you look at, dear students, you will get the volume for this riser should be greater than equal to, this is 3 times shrinkage volume of casting, it should be greater than equal to 658.125 centimeter. Okay, and based on this, if you are now calculating the riser diameter, that is volume of riser is what? Cylindrical riser is pi by 4 d square h, and they are saying here height is equal to diameter. So if I write here this pi by 4 d cube is equal to what? 658.12, then I can get here this diameter as 658.12 multiplied by 4 divided by pi, and cube root of the answer, how much it is? 9.43 centimeter. So this is the diameter that you have obtained by session duration, may be maximum 1.5 hours. 1.5 hour. Session length will be maximum 1.5, that is 1.5 घंटा. कितना घंटा? 1.5 hour. 1.5 hour. So it should be limited to 1 hour only, but I will extend up to 1.5 so that we can try to have the maximum questions, maximum practice here. Okay. So now, dear students, when we calculate the diameter from the necessary condition, now it is our prime duty to check whether the calculated diameter is going to give the response for the next condition, that is sufficient condition. What is the sufficient condition? That the riser should solidify after the casting. Okay, so this is the sufficient condition, right? So that is tau for riser should be greater than tau for casting. So what is tau for riser? We know when we calculate the modulus of riser, it is famous, very famous. For the spherical it is d by 6, for side cylindrical it is d by 6, for top cylindrical it is d by 6. So it is d by 6 should be greater than equal to this volume of casting divided by surface area of casting, that is nothing but the MC. Okay, now check here. What is D? You have calculated 9.43 divided by 6 should be greater than equal to MC is what? Volume of casting divided by surface area of casting. So it is cube here, isn't it? So volume of the cube, A cube divided by surface area 6A square. So it will be A by 6. So check it out. A is what? 15 centimeter divided by 6. So what happened? Now check it once again. So whether the 9.43 getting more than 15, it is not possible. So it is wrong. So whatever the diameter you have calculated, okay, is not satisfying the sufficient condition, dear students, and that is the reason why we have to recalculate the diameter, because this second condition is not going to get satisfied by the calculated diameter, which is 9.43 centimeter. Okay, so that is the reason why when I recalculate, so d by 6 should be equal to what? This 15 divided by 6, that is diameter should be equal to 15 centimeter. So this is the correct answer, dear students. 9.43 cannot be the correct answer because it is not, even though volume condition it is satisfying, but the very important condition is that it should also satisfy the sufficient condition, that is riser should solidify after the casting only. Now you will ask, sir, why we are not directly go with the second condition directly? You are getting the correct answer here then. So only thing is that we are not just calculating the or designing the riser with the layman technique. We are the engineers. We want to optimize the things. In case of processing or in case of the costing, we want to optimize all these things. We want to optimize the cost, we want to optimize the effort of the man who is making that, we want to optimize the process, all these things. So that is why we are go step by step, and then we are getting the correct dimensions when we apply these two conditions. Otherwise, see, when you are calculating by the first condition and this condition also gets satisfied, so you know that whatever the calculated diameter by the first condition is okay, but dear students, this is if not satisfying, what to do? That is very important condition. Riser should solidify after the casting, isn't it? So now correct diameter, what is the answer? So diameter is what? 15 centimeter, dear students. 15 centimeter. This is the answer, and this is always satisfying the sufficient condition, and that is tau for R is greater than equal to tau for casting. I hope it is clear. I hope it is clear. Abhishek, Akhilesh, Karthik, Banuranjan. So dear student, this is the crash course. Please inform your student, inform to your friends, your friend circles, your social media platform, everywhere. Just send this information to those people who are not aware of this. Today onwards, we have started this crash course on the particular subject, production engineering. Within 8 days, we are trying to cover all the topics with some important numericals. Okay, hoping that you should have some basics of that particular topic. So take this question for the homework. Okay, and tomorrow's topic will be the welding technology. Okay, welding technology, tomorrow's topic. And again on welding we are going to see some nice questions, nice numericals. Okay, I hope it is clear. So these questions can be very easy, this also very easy. We are running lack of time. Just tell me the match the pair, just tell me what is the answer. Continuous casting, which is also known as the strand casting. Long continuous slabs of the material gear are getting manufactured by this, so it is P3. Die casting uses pressure during the it is very high pressure we are using there. Shell molding, automobile transmission parts, that is correct. Slush casting, used for making the ornamental decorative parts or object. Squeeze casting, yes, you are going to apply the pressure during the solidification of the molten metal, so this is correct. So it is P3, yes. Q4, so option D, I hope it is correct. Option D, it is correct. Okay, So in this fashion you can solve this question, dear students. And see, I recommend you this Vision 2022 course, dear students, if you are right now at the second or third year engineering. So definitely this course is very ideal course for those students who are in the second and third year. You can see the course details. Okay, no one in the market is providing this much things, dear. Please, any query you can contact on this number. These are our faculties, top faculties from the Gradeup. These are our achievers. And dear students, do follow me on the Gradeup app. Do follow me on the Gradeup app. Tomorrow once again at 7, every day 7 p.m. I will be here discussing the subject production engineering. So today we discuss about the casting. Tomorrow the topic is welding technology. Welding. Thank you so much for joining. Thank you so much for joining, and do join the tomorrow session also. Inform to your friend circle. Put this information on your social media platform definitely, and be there in the huge numbers. Thank you so much, dear students. Good night. Take care. Bye bye.